Construction material, I'll be walking you through our MATLAB project. So as a little background, we selected our dataset from Kaggle.com. The title was 20 Years of Games. This dataset contained over 18,000 games released from the years 1996 to 2016, and other information pertaining to each particular game. For example, the date it was released and the score it received. So we had three preliminary questions when starting this project, and they were the following. One, what is the correlation between the number of games released and the average score? Two, what platform and genre were the most prevalent within the dataset? And the third was what year attained the highest average score and what year attained the lowest average score. So there were two fundamental concepts that we wanted users to come away with a better understanding of, and that was the overall trend of the game releases within the 20 years. And the second was how each platform and genre within the dataset affected and shared the totality of the gaming market. So without further ado, I will introduce the project by loading everything into MATLAB. So what you want to do is unzip the file and drag all of the 10 files into into MATLAB right here, and you simply go to project main script and run it. I'm not going to do that yet because I want to introduce each function first. So the first function I'll introduce is the import file function right here. So this import file function was generated by MATLAB, and it basically loads all of the data from the Excel spreadsheet into MATLAB, and it outputs 11 variables that are all equal to the column vectors of the data set, and all the names were given in accordance to the names of the columns of the original data set. So for example, title 1 contains all of the titles of the games within the data set, and same with all the other variables right here. And so all the output variables from this function are directly inputted to this matrix, to this function, make matrix. So as you can see, all the output variables right there. And the sole purpose of this function is to categorize the data types in order to prevent data type overlap and to make the whole indexing process of our other functions extremely easy. So as you can see, we have the numeric matrix right here, and the string matrix, it just concatenates all the numerical data type variables, and the string matrix concatenates all the character data type variables. So the next function right here is the user input function. So this function contains our main menu, which allows the user to choose from all of the graphing options and the lookup item option and to end the program if they feel they want to. And it's all in case of while loop to ensure that the menu is available to the user until they decide to end the program entirely. And it's also embodied in a switch case statement that calls the corresponding function depending on the option chosen from the menu. So the next function I will go over is the scatter graph function right here. So this function contains one menu, which allows the user to select the score versus release month option, the score versus release year option, and the score versus release day, which is the line graph option. The first two are scatter graphs. So the user is prompted to enter a month and a year, and this if statement right here just checks to see if they input a valid year for the data set. And and so the for loop is set to 18,626 iterations in order to check each row of the year and the month columns within the data set. The if statement, case in this for loop, compares and creates a new matrix if the conditional statements are true, and this new matrix contains each score for the games released in the input month/year. So it subsequently plots the scatter graph, and it determines the independent variable by taking the length of the newly created matrix from above, and it plots it accordingly. And also outputs the mode score during this particular month of the given year. So for case 2, it's basically the same coding mechanism, except the user is prompted to enter a year instead of a month and a year. And it's the exact same if-else for loop construct right here, and whenever the year occurs, the score is indexed into, and the if statement is, the if state's conditional statement is true, it indexes all of the scores into the new score matrix, and it also plots everything right here using the same mechanism described above, and also outputs the same concatenated string for the mode score. For case 3, it's a little bit different because it plots a line graph. So the user is prompted to enter a year, a month, and a day, and so the if else statement, it has an additional conditional statement to check for the day, and it uses the same new score matrix, and it's plotted basically the same way, except it's just not a scatter plot. So that's the scatter graph function right here. The next function I'll go over is the pi graph function. So this pi graph function is extremely long, and the first primary menu of the pi graph function is gives the user to choose from the options each genre share the market, each platform share the market, editor's choice, and score phrase. So for case 1, all the genre names are arbitrarily named and set equal to 0 for the counting purposes. And the following for loop it checks each row of the genre column within the string matrix, and whenever these genre names occur, it simply adds 1 to the genre variable, and that way it counts every single genre within the dataset. And this genre vector right here concatenates all of the new variables, and this is directly input to the pi graph function, and it's labeled, these labels for the cell array are input into the legend function, and it also displays a table that gives a more concrete overview of the number of games released for each genre. So for case 2, it leads to a nested menu, which consists of major platforms, PlayStation consoles, Nintendo consoles, and Xbox consoles. So for case 1, the 5 major platforms, Nintendo, Xbox, PlayStation, computer, and mobile, are all set equal to 0, and they're all arbitrarily named. And the same mechanism is at work here. searches throughout the first for this, it's the first row or the first column within the string matrix, which contains all of the platform strings, and then it adds one to the following variable whenever any of these statements are satisfied. So that way it checks and accumulates the sum of all of the major platforms, and then subsequently plotted using the same concatenation technique and the pi graph function. For case 2, it does the same thing for PlayStation consoles this time. So each PlayStation console is set equal to 0, and it is accumulated through this for loop. And it's plotted using the same mechanism. A lot of this code is redundant, but it all showcases different information. So the Nintendo section does the exact same thing as PlayStation and the major platform section, and same with the Xbox case statement as well. However, now we are out of the main, out of this nested menu and back to the primary menu of this function, and this is the editor's choice option, and it simply just checks for any occurrences of y and n within the fourth column of the string matrix, and if any of these occur, it just simply adds one to the arbitrarily named variables yes and no, and it plots a pie chart for the editor's choice. There's only two things that compose that graph. So for case 4, it leads to another nested menu, which encompasses score phrases. So it gives a user to choose the options between all phrases used, positive phrases, negative phrases. So it's the same counting mechanism, except this one counts all of the score phrases used within the data set, and it plots a pie graph accordingly. And case 2 counts all of the positive score phrases, does the same plotting mechanism, and case 3 counts all the negative score phrases and subsequently plots everything. And case 5 allows the user to return to the main menu. So from here, I will go to the bar graph function. So the bar graph function is extremely long, so I'll try to be as detailed as possible here. So this case statement is executed if the user selects average score per year option, and each year is given a variable name and set equal to 1 in order to simulate a row position for the vectors created below, which I will go into more detail in a few seconds here. This if-else statement is in case within this nested for loop that simultaneously checks for the year 1996. However, it changes within each else-if construct all the way to 2016. So as you can see, this bar year vector here, the first one would constitute 1996, and the second one would be 1997, and so on. And and if any of these conditional statements are true, the score will be indexed in the bar year score, and the initialized value will increase by 1 in order to keep track of the row positioning. So the other else if statements check for the other years until 2016, create a vector that contains the score for each game released during that year. So these newly created variables are set equal to the mean of each vector. These new variables right here are set equal to the mean of the vectors created above through the if-else for loop construct, and then these values are concatenated into one big vector and then subsequently plotted using the bar graph function. And it also outputs the highest average score for a particular year and when it was achieved using the max function, the position output, and the max value output. So for case 2, it's basically the same. The case statement is executed if the user selects average score per month for a given year, and each month is given a variable name initialized to 1 to simulate the row position of the newly created vector, and these variables are set equal to empty matrices in order to prevent MATLAB from erroring out in case the user inputs a year that has a month that doesn't contain any data. The user right here is prompted to enter a given year in the preceding if-else statements in case in the for loop indexes the score for each month from the year that was inputted, and it subsequently plots everything and takes the mean. As using the same coding mechanism of above, it's pretty redundant, but it does do totally different. It definitely displays two different types of data. So for the case 3 statement, this is a bit different from the others. It allows the user to enter a year, and it simply graphs all of the games released within each month of that given year, and it arbitrarily. All these variables are arbitrarily named and set to 0 for counting purposes. And this if-else construct, in case in the for loop, goes throughout the entire data set and keeps track of all the games and simply adds 1, and then all these variables are concatenated into one vector and subsequently plotted. The same goes for this case statement, which actually displays all of the games released for each year in a bar graph, and using the same if-else for loop construct, and everything's plotted, except here we use the curve fitting, and we also use a data manipulation to extrapolate a value for when the user is prompted to enter a year after 2016, and that value is then input into the curve fitting function, which computes the estimated value of games released during that year, and it plots it. So in case 5, allows the user to return to the main menu. Okay, so for the next function, I'll go over the lookup function, which is a pretty long function as well. These functions are all very long. So case 1 allows the user to enter a game, and it subsequently displays a table with all of the information for that game. And so this for loop checks for any occurrences of this game title, and it indexes into these two variables, numbers and strings, and right here further categorizes all of these matrices into the score, the release year, release month, according to whether it's indexed from the numeric matrix or the string matrix, and all these variables are subsequently input into the table function um, and output it as a table. So for case 2, the user is prompted to enter a year and a month, and the same coding mechanism is at work here, except it just checks for occurrences of of when the input year and the input month are the same, or for when the input year and input month occur, and it simply does the same categorizing mechanism as described above, and displays all of the titles of the games released during that year and the month, and all these other pieces of information. It also prints the number of games within that month. So for case 3, the user is prompted to enter a specific genre. However, the genre is this genre cell array is displayed to the user prior to the input, allowing the user to choose from the to choose from this assortment, and it goes through the same for loop iteration to check for any occurrences of these genres, and then it's subsequently categorized as with the previous, and it's input into the table function and displayed. So the same goes with the platforms. It's the same coding mechanism as before, and it's all displayed in a table, and it also displays the total number of games released. All right, and so for case 5, it displays the score phrases and allows the user to input any score phrase available, and it's displayed to the user prior so they don't have any confusion. And it's the same indexing process and looping process and categorizing process, and it also displays a table. For case 6, it's a little bit different. It allows the user to choose from this nested menu for a specific platform, Nintendo, Xbox, PlayStation, and PC Mobile. And this simply just displays the number of games released within the particular platform, similar to the pie graph, except it explicitly gives the number of games. So it's used. So if any of these strings occur, Nintendo is increases by 1, and this is how the counting this is how everything is counted and displayed to the user. So the same thing goes with Xbox, PlayStation, PC games, and mobile devices. And the user is offered the option to return the main menu. So for the last core function right here, we have the histogram function, which displays the frequency of games released, the frequency of games received, the number of games given a specific score within a particular interval. So for example, from 0 to 1, 1 to 2, 2 to 3, and so all of these are set equal to 0. And in this for loop goes throughout the data set and checks for these conditions to make sure the score was greater than 0 and less than 1, and then it increases the score interval variable by 1, and the same with the other ones all the way through 9 through 10, and then all these are concatenated into one variable right here, and it's subsequently plotted as a histogram function. We also use curve fitting here to see if there's any correlation. There wasn't. Spoiler alert. And it also displays a table with all of the games that were in each interval. So from each game that was from 0 to 1, 1 to 2, and so on. So those were all the core graphing functions. So now I'm going to go through some of the results. Unfortunately, this function or project consists of a lot of lines of code, so I will try to go through as many options as possible here. So I will also make this, I didn't mean to decrease the size of the screen. So it's basically loading everything in MATLAB right now, and I will actually I'm going to show each result from each function. So the score versus release month for the scatter graph, I'll input the month 11, November, and 2008. And here is the scatter plot for this, and so it details each score for each of the games released. So here you can see the first game that was released was given the score 5. It's kind of hard to see each of these, to depict each of these scores, but sure enough, it is accurate. So for the bar graphs, I will display the average score per year, which this turned totally big screen. Did not mean for that to happen. I'm going to, my computer is, okay. It's going to make this easier on myself. Okay, so this was the average score per year, 1996, 1997. So our initial question was, is there a correlation between games released and the average score? And the answer is no, there's no correlation here. It's totally arbitrary. And so that was one question that we answered. And the next thing, this also answers our other question, to what year attained the highest average, and that is displayed right here in the command window, and the highest average score was 7.6595, which was achieved in the year 2015, so that's pretty interesting to note. Okay, so I'm going to go through the pie chart. There are so many options, I cannot go through each of them because this video will literally be an hour long. I'll go through the Nintendo consoles option. This is just loading in. So this is all of the Nintendo games within our data set and the percentage of each that occurs. So 35% was the Wii took up the most as 35%, while NES took up only 1%, so that was the least. Okay, and also displays this table right here with the number of games. For I'm sorry, Nintendo 64 DD came in with the least. NES came in second to least. Okay, so the next I will go to the lookup item, and I will simply show this option. So this thing is in the way. Okay, so I will enter the genre platformer, and it will display all the platformer games within the dataset and all of the corresponding information, all of the score phrases used, the rating received, the year it was released, all that information. So for the histogram function, here it is, and the curve fitting, obviously. So the most games were actually given a score from 7 to 8, so that's kind of interesting to note. I'm glad the IGN isn't so pessimistic to give all these low scores. So actually, I want to show one more thing, which actually depicts some important part of our project. So each platform share of the market. So I'll show all the major platforms share of the gaming market, and this is pretty interesting to note right here. So each of these is Nintendo, Xbox. So PlayStation took up the majority of the market, and whereas the mobile games took up the least amount of the market. So that's a little bit surprising to us. We thought that Xbox may have came in first, but we were proven wrong. All right, so anyways, that is the entirety of our function. I'm sorry I cannot go through all the results of our function. It's truly an insane number of options I could have gone through, but this video will be way too long and I'm going around right now. So anyways, in conclusion, I thought this project really made me realize MATLAB's capacity it showed I'm sorry, it's really late. So this project really made me realize MATLAB's capacity to its versatility, and all in all, I think I became a lot better of a coder after this project. I think I finally understand the mechanisms of coding, and I think I have a better understanding of all of the different constructs and all of the different data manipulations and so on, if else statements, switch cases, for loops. It really increased my knowledge of all of these topics, and I think it was a success, and we definitely have a lot to showcase for this project, and we definitely learned a lot, and we hope others can learn from this project as well. Okay, that is all. Thank you for watching.